Okay, today's lesson we're going to focus on covalent bonding drawings using the Lewis dot structure. So again, here's the sheet that we're going to look at. We'll do a couple example problems. Again, what we need out is our periodic table because we have to look up the elements and their charge numbers and or their valence electron numbers. Also, what you have out is our notes. So we have these combined notes. This version may be slightly different than the one we did in class, but the main thing is that it tells us covalent bonds are made up of two or more nonmetals, and they share valence electrons. So the difference is when we draw these structures, we're circling where the pairs of electrons are being shared to achieve that octet rule, where that's different from the transfer of electrons where we're drawing arrows showing the transfer. Although with covalent, to get our formula, we have to use these prefixes to determine the correct formula of our bond, unlike the ionic bonds where we have to look up the valence numbers. Look up the charge numbers. So here we go. So on this worksheet, very first question is asking, what is a covalent bond? Well, we know that's when two or more nonmetal ions chemically combine. So we'll go ahead and write that in. So this is when two or more non-metal ions chemically combine. Question 2 is asking what happens to the electrons in a covalent bond. Well, the valence electrons, so when the electrons are talked about is actually talking about the valence electrons, and they are shared. So valence electrons are shared. Okay, so the first example we're going to do is number 4, phosphorus trihydride. So phosphorus, since it's just its regular name, you just look up the symbol, which is letter P. So, and since there's no prefix around it, it's just the letter P. There's one atom. Now, trihydride. Now, hydride stands for hydrogen, but the tri, if you don't remember, look at your notes for your prefixes. Tri means 3, so there's 3 hydrogens. So we write it as H3. Okay, so we're going to draw one atom of phosphorus and 3 hydrogens. So we're going to do it like so. The single atom is going to be our center atom. So you're going to put P right in the middle, and you're going to have and for phosphorus, letter P, it has 5 valence electrons. So we can put 5 dots around it. So we're going to go 1, 2, 3, 4, and 5. Now for the hydrogen atoms, there's 3 of them. Since this is already a pair, it kind of makes sense where my 3 hydrogens are going to go. I'm going to put one off to the left, one below, and then one off to the right. Now each hydrogen only gets 1 valence electron, so we'll just put 1 dot next to the symbol. So there's 1 there, 1 there, and 1 here. Now to show where they're a shared pair, we're going to circle them. So they're going to share there. There's another pair being shared, and then a third pair. So by looking at this chemical bond is stable because phosphorus that started off with 5 valence electrons now actually has 8. 2, 4, 6, 8 by sharing with 3 hydrogens. Hydrogen is one of those that's unusual. If you remember hydrogen, when we talked about the levels of our energy levels, it only takes 2 electrons to be filled. So hydrogen is balanced too, is full. 2, 2, and 2. So by making this combination, there's this chemical combination is now stable. So the others you can do in a similar way. Just look at the name of the compound, write the formula. However many atoms there are is how many symbols you place. Put the valence electrons around it, and then go ahead and circle those bonds until you get that octet rule. All right, that concludes this one.